Good morning, everybody out there in YouTube land. This is a little video called Introduction to Breaker Boxes. And what this is a new breaker box that was installed in this older home here some years ago. When you do an electrical system upgrade on these houses, on these older houses, if you buy a real old house, what you may have in it is a fuse box, and modern day breaker boxes have replaced all of the old fuse boxes, and some of the older houses may have breaker boxes in them, but they will be small breaker boxes. They won't have very many circuit or places to hook up circuits. The reason for that was when electricity was first put into homes in this country, basically all you had was electric lights. So you had basically you didn't need a whole lot of current for an electric light. So a lot of houses, when they were first wired for electricity, they didn't have any plug-ins at all. All they had was electric lights hooked up to the electricity, and you would have an on-off switch and that would be all you had in some of these older homes where they were first hooked up for electricity. Later on, you started having appliances that would plug into the electricity, so you started having wall plug-ins, but not very many appliances. So the houses that had wall plug-ins, some of the early houses, they would only have like one plug-in per room, and some of them would not even have that. So some of the early homes would not have very many plug-ins for a room. Nowadays, the building code, I know in the area that I'm in, the building code requires that you have a plug-in on each wall, at least every 6 foot of wall length. As you go along the wall, along the bottom, you need to plug in about every 6 foot. So on a wall, I mean, if it's about 15, if the room is by like 15 by 15 square feet, that is 15 feet by 15 feet, and you will need 3 plug-ins on each 15-foot wall. So you'd need a total of 4 times 3, which would be 12. Now, of course, you're not supposed to put them above electric heaters, because what happens is they'll fall down, the cords will fall down on the electric heaters and burn, so you don't have to put the plug-ins there. So anyway, let me go ahead and run through this breaker box here real quick to give you kind of an idea of what's going on. If you look right up there on top, that's the main power on-off switch, and that'll tell you right there that this is a 200 amp breaker box. That 200 is for amperage. That's 200 amps. 200 amps will run a lot of things, a lot of electric heaters. It'll run an electric stove. It'll run a lot of things. An electric stove actually consumes one heck of a lot of amperage in a modern day home. And most electric stove breakers, if you take a look, they will be 50 amp breakers. And if we look down through here, we'll see right there is a 50 amp breaker. And that is for the electric range. If you ever look into a breaker box, you'll see a 50 amp breaker. That will be for the electric range, because if you get all the eyes going and the oven going, that electric range is pulling a lot of amperage. So your big main double breaker in your fuse box, and this is a double breaker. You can see the two things are hooked together here. The two leads are hooked together. And that's for an electric range. Now, if you look at some of these others here, you know, there's a 20 amp double pole breaker. These are called double pole breakers, and they're for 220 or 210, however you want to say it. In your electric homes today, you have two different types of amperage, or two different types of voltage that's used. One is 220, which is, or 210, which is twice 120 volts AC. And if you wonder why it's called 210 and that's twice 120, it's RMS squared, so it's not really double. Some people will say 120 and 240, but a lot of times you'll hear like 120 and 210. But anyway, these over here, these little ones here that you see, that's a 20 amp single pole breaker. You notice they're not hooked together here. Here's a 20 amp double pole breaker. Now this particular box here has a lot of double pole breaker, 20 amp breakers, and the reason why that is this house originally had a lot of electric baseboard heaters in it, and all the single pole breakers in here that you see, like there's a couple right there, those are for the there's another single pole. Those are for the wall plug-ins and for the lights. And there's another single pole, a double pole down there, another single pole, another single pole over here, double pole, that's for electric heater. And there's a double pole right there, electric range. Also, one of these double poles will be for a, there's a single pole right there. And there is a double pole. Now you take a look at the electric range there. We have that cut on, and this right here, this double pole here for an electric heater, they're all cut off. All the double poles for the electric heaters are cut off because the people in this home do not use those electric heaters because they consume a lot of power and they'll really drive your electric bill up. Anything that consumes heat or takes heat away, like air conditioning, will use a lot of electricity and will really take your electric bill up. So there's your on-off switch, and it's a 200 amp breaker box. You just pull it over to the, it says there on-off. It's on right now. You pull it over to the other position, it'll be off. These circuit breakers down here, what happens is, like I told you down here on this one here, the 50 amp, that's on. The 20 amp there, that's off. Now, when these things kick off, when you're pulling too much electricity, they will just barely kick. And you'll look at your breaker box and you'll say, one of my breakers kicked off. And then you'll look at it and you'll say, well, it looks like they're all on. In reality, they are not, because in order to be off, they just need to kick off just a very little bit. So what you have to do, you have to shut them all the way off and then pull them all the way back on. But anyway, that's a little bit about breaker boxes. And as you can see, this breaker box here is full. You don't have any more spots for to put any additional circuit breakers in, or any circuits in. What happens is a lot of these 220s here, or double pole breakers, are not being used because some of those electric heaters have been disconnected. So those can be taken out, and you can put another double pole in there or put another single pole in there if you want to. Very important when you're working on the electric system is to have this main breaker turned off, all the way off. And the way you take the cover off is you got these screws up on the ends. You can take the cover off and you can get in there and you can take these breakers out, circuit breakers out, and put others in, and you can rewire on the inside of the box. But anyway, that's a little bit of an introduction to circuit breaker boxes and what the circuit breakers look like and what the single pole and double pole looks like. So anyway, I hope you enjoyed the video, and if you did, please subscribe. Thanks, appreciate it.